Okay, hello, you're welcome to my channel. Now in this video, we want to evaluate the limit of the following functions as x approaches infinity, alright? So this kind of limit, we call them limit at infinity. Good, so we want to check how the function behaves as the input gets larger and larger. Alright, so the following functions are just rational functions, alright? Where we have polynomial in the numerator and a polynomial function still in the denominator. Great, so let's start with the first one. But actually in this video, we're going to solve only the first two, and then I'll show you something that will lead you to the third question and the fourth question in our next video. Alright, so we have the first one to be the limit as x tends to infinity of 1 over the x squared minus x minus 1. Good. Well, as x tends to infinity, let's see what we've got. If you plug in infinity in that place, right, just in place of x, you'll be having, x squared. As x approaches infinity, if you square it, it will be still infinity, right? Okay, and then minus infinity, which tends to be a little bit problematic. So the way I would like to approach this is to rewrite the function a little bit by factoring out 1 over x squared. This is what I would like to do. So I will take this to be, now you factor out 1 over x squared, we're going to have, factor out x squared first. So if you take out x squared, the denominator, right, this is what we get. We're going to have this place will now turn to 1 minus 1 over x, then minus 1 over x squared. That is what we get when we take out x squared from the denominator, all right? Okay, good. And now I'm going to split this fraction into 2 as I take the limit of the product. That will become the limit as x tends to infinity of 1 over x squared times 1 over 1 minus 1 over x minus 1 over x squared. Good. So after taking out x squared, we are left with 1 and so on like that. We now split the fractions into 2 parts, which is still a product. Okay, so here we know that the limit of product is the product of the limits. So this will give us limit as x tends to infinity of 1 over x squared times the limit as x tends to infinity of this function, right? Okay, so let's see what we've got. As x tends to infinity, 1 over x squared will tend to 0. Reason being that as x tends to infinity, we're going to have x squared, all right? So you're squaring very large something. The result is going to be very large also in the denominator. So we're having 1 over something very large. In fact, the result is going to be 0, as we've argued, all right, in our previous videos in this course. So just check the playlist where we have limit at infinity as an introduction to you. Good. So the second part, we're going to have limit as x tends to infinity of 1. Well, the numerator is still going to be 1. This place will now be 1 minus, as x tends to infinity, we know that 1 over x gets to 0, right? And in the same vein, as x tends to infinity, 1 over x squared tends to 0. Good, because the denominator is increasing without bound. The result of the fraction reduces without bound to 0. Good. So in the end, we are entering with 0 times something, right? So this is 1 over 1. 0 times 1, the result of this limit is just 0. Okay, so that's it for the first question. All right, let's go over there and solve the second question. We have here to be good. And now let's see, when we have this kind of limit as x tends to infinity of rational functions where the numerator is a polynomial and the denominator is the same, what we need to do here is to divide numerator and denominator by the highest power of x in the denominator, right? That was what we did here. We divided the numerator and denominator by x squared, which I didn't actually state. So here we're going to divide the numerator and denominator by the highest power of x in the denominator, or say by the highest exponent. So the highest power of x in the denominator is 3, right? We're going to have to divide numerator and denominator by x raised to the power 3, right? So that will give us limit as x tends to infinity. So if you divide through the numerator by x to the power 3, you're going to be left with 5 minus 2 over x minus 1 over x cubed, right? Divided by, we do same to the denominator, we're going to enter with 1 minus 4 over x squared plus 1 over x cubed. So you just do the divisions, you will see some things will cancel, some will not. Okay, as we've observed here, we couldn't cancel x with the x cube. And the same thing there. Right, good. As x tends to infinity, all right, let's see. This still remains 5 because that's just a constant. And then this is 2 divided by infinity, which is going to be 0, right? And then 1 divided by infinity, which is still going to be 0. Remember, the numerator is a constant, and the denominator is approaching infinity, which has passed any real number at all. So we're having 0 there. Then the whole denominator, we have 1 minus, this is going to be 0, and then we add it with 0. Good. That's just from the fact that 1 over x raised to some power, as x tends to infinity, the result of that fraction, this is going to be 0. Good. So this gives us 5 in the numerator and then 1 in the denominator. So 5 here is the result of that limit. All right, good. Okay, let's move over to the next video and check the limit of these other two functions. All right, great. Okay, thanks for watching. Please subscribe to my channel.